Consider the region of the space enclosed by 3x plus y equals 6, y equals x squared minus 4, and x equals 0. We're going to calculate the volume of this region revolved around the y-axis. And there's a number that we give there and see if it's the right answer. So first thing you want to do whenever you draw these problems is just draw a picture. So I have 3x plus y equals 6. And we normally see it like this, minus 3x plus 6. So that's a linear equation. Crosses at 6. And here at 2, because you go down 3 and over 1, down 3 and over 1, and you end up right there. Now this does extend out, but we also have this equation y equals x squared plus 4, which crosses down here at minus 4 and has a y-intercept at 2. And again, you can graph these in your calculator. What you'll see is that this will extend down and this will extend up. But you want the region blocked out by x equals 0, which is what this line, this vertical line is. Y equal minus 3x plus 6. And then y equal x squared plus 4. Now, if I'm rotating this around the y-axis like this, it's going to look something like a top, like an old-fashioned top in 3D. Now, because if I'm revolving around the y-axis, I want to slice it to where the volume is going to be really easy to calculate. Doing it this way doesn't make sense if we're rotating it around the y-axis, so we have to slice here horizontally because we are doing the change in y this time. Now notice that the functions do change at the x-axis, so we have to do this in pieces. We're going to calculate the volume of the rotation on the top and the volume of the rotation on the bottom, and then we're going to add them up in the end to get total volume. So if I look at, regardless of where the slice is, it's going to look like a coin or a disc, real thin disc. Whose width or height, if you want to call it, is going to be the change in y. So we talk about the volume of the top slice. The volume of anything that looks like a disc is going to be pi r squared h. H for being the height, r being the radius. So right now we need to describe r, the radius of this thing, in terms of h. I'm sorry, in terms of y, because that's what our height is. That's what our variable is. So if you think about here, how can I describe the radius of my disk no matter where it is on the top based on this graph? Well, it looks like the radius from the center to the outer edge is dictated by this function right here. But if I put minus 3x plus 6 in here, that doesn't make sense because that's a y, and then I'd have x's in here. Everything has to be the same variable, namely y, because of the way we sliced it. So that means I have to take this function and solve for x. So 3x equals 6 minus y. Divide everything by 3. 2 minus y over 3. So this becomes 2 minus y over 3. Now the volume of the bottom slice is going to be pi r squared h. Again, always start there, especially when it's a disk, right? Only when it's a disk. Pi, and you got to calculate r. By the way, this has got to be squared over here. And again, my height of my disk is going to be delta y. This has to be a function of y right here. So I have to do the same thing to this function here, solve for x. X squared equals y minus, I think I have a sign error here. This should be minus here. Minus. So y plus 4, x equals plus or minus the square root of y plus 4. I'm going to choose the positive one because my outputs for this bit right here, all my x's are positive. So the only way that this is going to produce positive x's is if I take the principal or positive root. So that means what goes in here is the square root of y plus 4. Now again, I can't just add these two together now because they're two different disks. So this disk is bounded by this function, and this disk is bounded by this function alone. So what we want to do is integrate each one, add up all the sums of their volumes. So pi 2 minus y over 3 squared dy plus the integral of pi. Now the square root of y plus 4 squared is y plus 4. Now let's think about the limits then. On the top, if I want to take the top slice and the bottom slice and think about the bounds for y, the bottom slice is where y equals 0 and the top slice where y is 6. Down here, the slice clear down the bottom here is minus 4 and the slice clear at the top is 0. So we go from minus 4 to 0. Now let's calculate these. I'm going to use the calculator. I would suggest you practice it by hand too, to make sure that you remember how to do it. So in here I'm going to do 2 minus x divided by 3. And let's go here, 0 to 6. So it looks like my y value is going to be 0 to 2, x is going to be 0 to 6. 0 to 6, 0 to 2. Beautiful. Now if I do my, wait, that's not quite right, is it? I got to stick pi in there. See, this is a mistake that's easily made, by the way. I'm glad I made it. Pi. I have to put the exact integrand in there. 2 minus x divided by 3 squared. Well, that was going to be a huge mistake. Good heavens. Glad I figured it out. So now I want to go up to 12.566. So my window, instead of going up to 2, I'm going to go up to 15 or 13, say. Now my graph's going to look really different. Zoom. Second calc, number 7. My lower limit's 6. My top, let's try that again. Number 7, my lower limit is 0. My top limit is 6. And see what the calculator busts out here. 25.1327. 25.1327, and this is going to be volume, so units cubed. Plus, now let's do this next guy. Pi times x plus 4. Nothing squared in this case because it undid the radical, so that's all we actually have to put in there. Now I keep going over here to do the bounds, minus 4 to 0. I put my x bounds in the first column, and it tells me how to fix my bounds in the other column. So it looks like it's the same, except for x goes from y estimate of minus 4 to 0. So graph it. Do my calculations. Lower limit is minus 4. Upper limit is 0. And I get 25.1327. 25.1327 units cubed. That's the same. How funny. So if I clear that out, add those up. 25.1327 plus 25.1327 gives me 50.2654. 50.2654. Now it looks like I'm off a little bit up here. What I used to get this number here was the numerical program. So I used Simpson's rule, and because of the nature of the graph, it may have caused more error. But we're close within a couple decimal places, so I think we're good. So it's 50.2654 cubic units of this shape being revolved around the horizontal axis or vertical axis.